All right, let's discuss the first part of our solo test answers. The plants in level A require 7 kilograms of water to be pumped from the tank. What form of energy is required to store the water at the top of the lab? We're dealing with distance off the ground. That's gravitational energy. The plants on level A require 7 kilograms of water to be pumped from the tank. How much energy does it require to lift the water to level A? So 2 meters high. Again, we're looking at gravitational energy. There's our gravitational energy formula. So I plug everything in. I write out my general formula, plug in my givens. 7 times 9.8 times 2 gives me 137.2 joules of gravitational energy. Number 3, which pie chart represents the transformation of energy as the water returns to the tank? Assume there's friction between the water and the tubing. Starts at the top is all gravitational. It's all off the ground. Then it starts to move towards the ground, still off the ground, so still gravitational, but it's moving, kinetic energy. There's friction, so there's dissipated energy. Once it hits the ground or almost hits the ground, there's dissipated energy, it's slowed down, but most of that energy is kinetic right before it hits the tank again. It requires 117.6 joules of energy to bring the water to level B, which is 1.5 meters high. What's the mass? We're dealing with gravitational energy, and I'm solving for mass. There's my formula. Write out the general formula, plug in what you know. I know it's 117.6 joules of energy. I know 9.8, and I know 1.5 is our distance or displacement. Plug and chug, 8 kilograms. Number 5, the aquaponics lab requires high-powered lights to help the plants grow. What form of energy provides plants their energy? It's radiant energy. Light is radiant energy. It radiates out. Plants store energy as starches, allowing this energy to pass on to any Mars colonist that eats the plant. What form of energy is stored in the plant itself? That's chemical energy. It's when there's those bonds are broken down. We eat something, we're using chemical energy. What portion of the electromagnetic spectrum is being used to grow the plants? Well, it's visible light spectrum. We know that because those higher frequencies and shorter wavelengths are way to the right. These are high energy waves. Low frequency, high wavelength, or large wavelength. These are our low energy. Dead center is visible light. That's where we get all the light for plants. Plants' leaves are green because they reflect green light. We see what reflects. What two colors are being absorbed by the leaves? Red and blue. So if we look, if we have red and blue, that's magenta light. Green is being reflected, red and blue are being absorbed. What does not reflect, absorbs. Describe the transformation of energy as the 3D printer's electronic extruder heats up the plastics. We're going from electricity to heat, so electrical to thermal energy. That's how the energy transforms. Describe the transformation of energy as the 3D printer's electric motors move the extruder. So we're going from electrical energy to kinetic energy, electrical to kinetic, because we have electricity moving something. What portion of the electromagnetic spectrum allows us to send 3D printer digital files from Earth? Well, it's radio. Anything that requires a high frequency short wavelength would require a lot of energy. Radio waves, low frequency, large wavelength, low energy. So that's why we use radio waves. They can travel long distances without using a lot of energy. The 3D printer runs on a 120 volt power source, creates 500 ohms of resistance. I know voltage and resistance come together in Ohm's law. I want to find the current. My voltage is 120, my current is unknown, and my resistance is 500. What's happening to I? I'm multiplying by 500. How do I undo it? Divide by 500, 0.24 amps. The belt on the 3D printer is made of elastic or rubber, so it stretches, so we're dealing with elastic energy. We're trying to find just the energy. Here's our general formula. Our spring constant is 20 Newton meters. Our distance that's being stretched is 0.05 meters. So we plug all that in. 1/2 of 20 times 0.05 squared. Remember to square. If there's squares and square roots, students tend to forget them. It has about 0.025 joules of energy stored. If you're to let go of the 3 kilogram belt, so we know its mass, and it accidentally flies through the air while stretched, how fast would it fly? So we're dealing with kinetic energy, and I want to know how fast. So that's my velocity. Plug in what I know. My kinetic energy in the last one was 0.025. I know the mass is 3, so I just simplify what's in the fraction and take the square root, 0.13 meters per second, if you round to 2 decimal places. As the electrons flow through this 3D printer's extruder, they create a current. The flow of electrons is a current. The extruder heats up to melt the plastic because resistance creates friction for the electrons. This is why when you rub your hand, you feel heat. When electrons rub against resistance, it creates heat, or in this case, thermal energy.